called because of the top of the diagram, and those are your node switches at that level. And that's what a typical cluster looks like. That's a ball one, but others are the same. And I am going to finish on time. Examples of graphs of performance. Don't worry about the numbers, but this is a graph of bandwidth. And different vendors are trying to say, well, their server is better than others because my bandwidth is this or this. But my caution note is that number there, that's 10 to the power 7. That's like 10 million bytes. Nobody sends message, no application sends 10 million bytes from one processor to another. They send somewhere of the order of 1,000. It's a logarithmic scale. So if you're trying to choose your vendor, you choose one that's about here. And here, green is a lot better than blue. Whereas if you go over here, green and blue are the same. So don't be fooled into saying that these two, that your application will at the same speed as each other because the green and the blue there are the same. Because your applications are not there, they are there, or even over here. You can't see what's going on here. So finally, that's what it looks like. If you zoom in there, and that's the other metric that people care about is latency. Because they don't care about how... This is thing I finish on about fibre optic broadband. Fibre optic broadband has less bandwidth. So it has... Fibre optic broadband is slower than copper broadband. What you get is more bandwidth. You can send more data at the same time, but light goes down glass fibres slower than it goes down copper wires. So the time taken for you to send, if you're playing a game, the time taken for you to send an update to the server and back to the other person is based on the latency, how long it takes to send the message, not the rate you can send down it. So actually for playing games, you're better off with an old-fashioned copper interconnect to your house because fibre optic broadband is slower, it just has more bandwidth. So when your final word is, when you're looking at designing your system, make sure you know it's not all about bandwidth. It may be about latency or something else. And that's all I've got to say. Sorry, 2 minutes out, over time. Yeah, sure.
Given Intel's now on Cray and the idea, how do you see things kind of progressing going forward? What's going to win out? Might be
well, I think InfiniBand will probably die out. InfiniBand was designed not for supercomputing. It was designed really for connecting storage data centers, and it never picked up in that market. It found its niche in HPC. Intel have bought an InfiniBand company with the idea of putting that technology on the chip. So you may have servers which have the chips talk to each other via InfiniBand on the server, and may even talk to others over it. But really, what Intel are after is that technology, and what it turns out like is probably not going to be called InfiniBand. Cray, on the other hand, Cray have sold to Intel their technology, but they keep the ability to sell their own products. So Intel have taken that and probably are co-developing that in a parallel line of using Cray-like interconnects to connect the chips together. What both of those mean is that the future will be that Intel will have a dominant position. Intel are becoming probably too dominant because they have very good chips at computing. If they control how their chips talk to each other, then it locks out all the other vendors like AMD. If they control how they connect to each other. So maybe all supercomputers based on x86 will be possibly even sold by Intel, possibly so much so that companies like HP and IBM and Bull get bought by Intel, because if Intel make the switches and the motherboards and all the chips, then what is the role of us? That's, I guess, my caution note on that. Although the future is really ARM 64. That's a different conversation.
Let's thank Daniel.
Thank you.